Okay, so in this example here, we're going to be talking about how to find the polynomial if you're provided the zeros. Now, in this example here, we're going to be dealing with zeros that are both imaginary and complex. So we actually have already done a video on finding the polynomial given the zeros, but in the previous video, we were not dealing with imaginary and complex numbers. So you want to make sure that you're good at finding the polynomial if you're provided real zeros, because in this video here, we're going to be using zeros that are imaginary and complex. And I'll actually go ahead and link that video below in the description box so that you have access to that content and so that you know how to find the polynomial if you're given zeros that are real. Okay, with that being said, let's go ahead and start the problem. Now, you have two zeros here. You have negative 2i and positive 5. Now, we have to talk about this negative 2i. This is an imaginary number. We know it's an imaginary number because we see the I. Now, remember where I comes from. I comes from the square root of negative 1. So I is equal to the square root of negative 1, okay? And we know that the square root is always going to be plus or minus. So you have to be careful with these problems. When they give you an imaginary number or a complex number, you have to remember that there's two possibilities, okay? And so for this imaginary number here, I have negative 2i, but if a negative 2i exists, that means that a positive 2i must also exist. So even though they did not list it here, you have to recognize that. So I actually have another zero here, which is going to be positive 2i, okay? So make sure you check that before doing the problem. Now I have all of my zeros listed out. Now I can go ahead and put it in factored form, multiply it out, and then I can get the polynomial with these zeros. So let's go ahead and do that. Let's get rid of this stuff here. And again, we know that the other zero is going to be plus 2i. Okay. So again, if you want to find the polynomial, you have to put this back in factored form. So technically, these are the zeros, meaning x is equal to negative 2i, x is equal to 5, and x is equal to positive 2i. So if you put this back in factored form, you're going to be moving these numbers over to the left-hand side. So for example, this negative 2i, I would have to move it over to the left-hand side back into factored form. So just rewriting the problem, it would be in factored form x plus 2i, okay? And then looking at this one here, that would be x minus 2i, again, in parentheses. And then this one here would be x minus 5. And again, technically, this is all equal to 0. So if you were to solve each one of these factors, this factor here, this one, and this one, you should get these zeros, right? So essentially what we're doing, we're reverse engineering it. We're going in reverse. So rather than factoring it and trying to find the zeros, we're actually putting it back in factored form to figure out the polynomial in which these zeros came from, okay? So now that you have it in factored form, we're going to go ahead and just multiply it out. Now, here's my recommendation to you. You have three binomials here, okay? What I recommend you don't do is multiply this binomial by this binomial, because technically this binomial right here has an imaginary part. This one does not. So you want to keep the imaginary parts together and the real parts together. So what I'm going to do here, I'm going to multiply these two binomials first because they both contain an imaginary part. Okay, so multiplying this out, we're going to get x squared. And again, we are doing FOIL, so we'll get negative 2ix, and then plus 2ix. And then we'll get negative 4i squared, okay? Now we're going to go ahead and clean this up. These two terms right here will cancel out. We're done there. So we're left with x squared. And now this I squared, where does that come from? Well, we know that I is equal to the square root of negative 1. So we know that if we square both sides, we're going to end up with I squared equal to negative 1. So what I can do, whenever I see an I squared, I can replace it with a negative 1. So what's really happening here, I'm doing negative 4 times a negative 1. That will give me positive 4. So let's go ahead and get rid of this here. And we're going to rewrite it as not a negative 4i squared, but a positive 4, because we just talked about it, right? Because again, it's negative 4 times negative 1, so positive 4. There we go. And now we have this binomial here, x minus 5. We're going to go ahead and FOIL that out, and then we'll be done. And if we do FOIL, we get x cubed. Then we get negative 5x squared plus 4x and then minus 20. Okay, so this is done. We can't combine any like terms here. This polynomial is completely simplified down, and we're done. So this polynomial has the following zeros of negative 2i, plus 2i, and positive 5. Now remember, when you graph this polynomial, you are not going to see negative 2i or positive 2i because they're imaginary, right? So technically, if you were to graph this, you're only going to see it crossing the x-axis at 5. Okay, you won't see the negative 2i and the positive 2i because, again, we're dealing in the real plane, not the imaginary plane. Okay, so this is done. All right, let's go ahead and take a look at one more example. Now, this example is definitely going to be a little bit longer. And your first step, make sure that you are listing out all of the zeros. So right here, I have a complex zero, meaning I have a real part and imaginary part. So here's my real part and here's my imaginary part. Okay, it's just like an imaginary number, except you have a real part. So if a 5 plus 2i exists, that means a 5 minus 2i must also exist. We call that the complex conjugate, okay? So I'm going to go ahead and list that, 5 minus 2i, okay? And then I have this 3i. Well, if a 3i exists, that means a negative 3i must exist. So I'm going to go ahead and list that out as well. So you actually have 1, 2, 3, 4, 5 zeros here. This one's going to be a little bit of work, okay? So let's keep everything that's similar together. So when we put it back in factored form, I want to keep everything together. So I'm going to start with this 5 plus 2i. Remember, that's really x equals 5 plus 2i. So if I put that back in factored form, it's going to be in parentheses x minus 5 minus 2i. Okay, that's how it's going to look. Okay, so I'm done with this one here. I'm going to cross it out so I know I'm done. I'm now going to use this one here. When I put that back in factored form, that's going to be x minus 5 plus 2i. Okay, that one's done. Then I have 3i. When I put that in factored form, that's going to be x minus 3i. Okay, then I have the negative 3i. That's going to be x plus 3i when I put it in factored form. And then finally, I end up with this positive 2. When I put that in factored form, that's going to be x minus 2. So x minus 2, okay? So from here, we can go ahead and multiply it all out. And again, you want to keep the parts that are similar together. So for example, when I multiply this out, I'm going to work on these trinomials right here. I'm going to keep these together. These binomials I'm going to keep together. And then I'll worry about this x minus 2, okay? So let's go ahead and go for it. So when we multiply out these two trinomials, we should end up with 9 terms total. Let's just go right into it. So I'm going to do x times x, I get x squared. Then I do x times a negative 5, I get negative 5x. X times a positive 2i, I get plus 2ix. Okay? Now I go into my next term, which is going to be negative 5, and I distribute 3 times again. Okay? So I'm going to do negative 5 times x, negative 5x. Negative 5 times a negative 5 plus 25. Negative 5 times a 2i, I get negative 10i. Negative 10i. And now I move on to my last term. Right here, this negative 2i. So I'm going to do negative 2i times x, I get negative 2ix. Okay. Then I have to do negative 2i times a negative 5, I get plus 10i. So plus 10i. And then I have to do negative 2i times a positive 2i, I get negative 4i squared. Negative 4i squared. Okay, from here, look for terms that are going to cancel out. This is a big mess right now, but it's going to simplify down pretty nicely. So for example, I have a positive 2ix right here and a negative 2ix. That's going to cancel out, okay? Then I have a negative 10i and a positive 10i. That's going to cancel out, okay? Let's work on combining like terms now. So if I combine like terms, I have an x squared. Can't combine that with anything. So x squared. And then I have negative 5x, negative 5x. That gives me negative 10x. Okay. And then you have this positive 25, but you also have this negative 4i squared. Now remember, I squared is really negative 1. So it's really negative 4 times a negative 1, which is positive 4. Okay. So what I can do here is I can do 25 plus 4, which is going to give me 29. So plus 29. Okay, so all of these terms are used up. We're done with them. Okay, and now we can move on. So this part right here, right, we're just going to leave here for now. And we're going to work on the next part. We're going to work on these binomials up here. And again, we're going to do that by doing FOIL. So why don't we go ahead and do that one in a different color. So doing FOIL, we get x squared. And then we get plus 3ix minus 3ix. And then minus 9i squared, minus 9i squared. These will end up canceling out. That's what we want. And then we know that I squared is really a -1. So I'm going to do -9 times a -1. That will give me positive 9. So I end up with x squared plus 9. Okay? And so finally, I have this x minus 2. I need to multiply all three of these together. So I have to multiply this one, and this one all together. Okay? So why don't we go ahead and create a new page? That way we have a clean slate and we'll start multiplying these all together. All right, so I just went ahead and rewrote everything that we had. Now we're gonna multiply these all together. Now, it's not really a right or wrong way how you do it. Like I could take this binomial and I could multiply it by this trinomial. You could do that. Or you could take this binomial right here and multiply it by this binomial. And then you could multiply by the trinomial. It doesn't matter. But what I think I'm going to do is I'm going to multiply the two binomials first, and then I'll work on this trinomial. So doing the two binomials, I'm going to end up with x cubed. And then I get -2x squared plus 9x minus 18. Okay? And we're going to put this all in parentheses. So again, I just multiplied out the binomials. Now we have the trinomial over here, which is going to be x squared minus 10x plus 29. Okay, so now we're just going to multiply one more time and then we're done. So I have a trinomial here and I have to multiply it by this other polynomial here that has 4 terms. And that's exactly what I'm going to do. So I'm going to start on this x squared here. I'm going to distribute 4 times into this polynomial, and then I'll do the -10x, and then I'll do the positive 29, and then I should be done. Okay, so I'm going to do x squared times x cubed. That will give me x to the 5th power. Okay, then I'm going to do x squared times a -2x squared. That will give me -2x to the 4th power. And then I'm going to do x squared times 9x. I get plus 9x cubed. Plus 9x cubed. And then finally, I'm going to do x squared times -18. I get -18x squared. Okay, so I'm done there. Now I'm going to move on to -10x. I'm going to distribute 4 times, and then I'll go on to 29 and do the same thing. Okay, so -10x times x cubed, I get -10x to the 4th power. -10x times the -2x squared, I get plus 20 and then x cubed. -10x plus 9x, I get -90, and then I get x squared. And then I do -10x times the -18, I get plus 180x. Plus 180x, okay? So I'm almost done. I have this last term right here, which is plus 29, okay? So let's go ahead and do that, and then we'll be done. So we're going to do 29 times x cubed. That will give me 29x cubed plus 29x cubed. Then I'm going to do 29 times a -2x squared. That will give me -58x squared. Then I'm going to do 29 times 9x. That will give you plus 261x. And then you're going to do 29 times a -18. And that's going to give you -522. So -522. Okay, so you have this big mess here, but you're going to clean it up, and then we will get the polynomial with the following zeros that were listed at the beginning. So let's go ahead and do that. Now I'm going to start with the highest exponent value. I have x to the 5th power here. I cannot combine that with anything, so I'm done. I'm just going to write x to the 5th power. Okay, now I'm going to move on to x to the 4th power, and I have -2x to the 4th power here. I have -10x to the 4th power here, and that's it. So if I combine, I get -12x to the 4th power. Okay, that's done. That's done. Now I have to move on to the third power. So 9x cubed, I have that. 20x cubed, I have that. And then the 29x cubed. When you combine all that, you should get plus 58x cubed. So plus 58x cubed. Okay, so that's done, and that's done. Now I move on to x squared, which is going to be right here. I have a negative 18x squared and a negative 90x squared and a negative 58x squared. So when you end up combining all that, you should get negative 166 x squared. Okay, so that's done, and that is done. And now we move on to x. I have 180x, I have 261x. That ends up giving me plus 441x. Okay, that's done, and then I have negative 522. I can't combine that with anything. That's it. Okay, so this is going to be the polynomial with the following zeros that was listed at the beginning of the problem. Okay, so that was definitely a lot more work than the other one. But again, if you follow the steps and you're careful with your math, you should get the polynomial at the end. So that's pretty much it. All you have to remember is make sure that you put it back in factored form at the beginning and then multiply it out. Now, if you're given imaginary or complex zeros, like we were in these examples here, you have to make sure that you include all of them. Because if they give you a zero that has an I in it, whether it be imaginary or complex, I does come from the square root, meaning it's always going to be plus or minus, and you have to include that in your list of zeros. If you don't include it, you're going to get it wrong, okay? So that's pretty much it. I hope that you gained something from the video. I hope that you learned something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to this channel so you get more math videos in the future, and I'll see you in the next one.